Good morning, everybody. I'd like to welcome you to the 52 North GI Innovations free webinar series. My name is Ann Hitchcock from 52 Degrees North. Today's webinar is how to apply sensor web technologies to provide Inspire compliant download services for observation data. Before we start the webinar, we have some organizational information for you. Just so that everybody knows, we will be recording the webinar and we'll publish it on our YouTube channel for the public. If you have questions during the presentations, we kindly ask you to write them down in the chat space. This is down around here. And we will answer them at the end of the presentation. We will have a session for discussion and questions. At the end of the webinar, we will delete our chat log. And if you're interested to know when the video is published for the public, please send us an email to info@52north.org. And I'd like to get started and pass over the presentation to Simon Jirka.
Okay, thank you very much. So also from my side, I would like to welcome you to this webinar. So we are happy that we have a couple of guests supporting us with this. So on the one hand, Alexander Kotzev from JRC will introduce a bit about the European background of the work on SOS, using SOS for Inspire download services. We'll have Michael Bouffi from BRGM as a user and one of the first organizations to adopt the SOS for sharing observation data in an Inspire compliant manner. And myself, Simon Jirka, I'm from 52 North, where I'm coordinating the sensor web activities. I will introduce a bit of the technical work in this context. So with that, a quick look at the agenda. So we will get a quick introduction from Alex about the European context, the motivation for handling observation data in Inspire, and Inspire download services in general. Then I will give an overview on how to use the OGC SOS standard as an Inspire download service, some technical aspects here. After that, we will have Michael from BRGM to introduce their architecture, their setup, as well as use cases. And then we will close with some time for questions and discussion, if there are any, where you can post, as Anne mentioned, your questions into the chat, and then we will answer them at the end of this session. Okay, with that said, I would like to hand over now to Alexander Kotzev from JRC for his introduction into the topic from a European perspective. So, Alex, the floor is yours.
Thanks a lot, Simon. Thanks to you and to Anne for organizing this webinar and for inviting me. It's a pleasure to share some developments on the European level that would be important within the context of the discussion we are having today. I would like to start with saying a few words about the European data economy, which is part of the flagship initiative of the Juncker Commission that deals with the digital single market. I would like to start my presentation with the European data economy because as we see from the slide, its value is currently more than 300 billion, and it is estimated to be growing to more than 700 billion by 2020, which would represent quite a substantial share of the European Union GDP. To just put things into perspective, there's a lot of discussion now on defense budgets. As you know, there was a NATO summit yesterday. Currently, there's 1.4% GDP allocation on a European Union level for defense. So really, really substantial contribution of the data for the European economies. if you're one is wondering what's the direct relevance to our discussion today, well, there are several policy documents that were relatively recently launched that give guidance, give strategic direction on how to make the most out of the data economy. And Inspire is acknowledged within that context as a best practice. First. Second, those documents actually talk about observation data. So we see on the slides, it's about raw machine generated, so Internet of Things content. It's about data from industrial platforms and data from citizens. This is all spatial data, and the big portion of it is spatial data and also spatial temporal data. Inspire within this communication and staff working document for building the data economy is acknowledged as a best practice. For a good reason. When we look into the implementations on a European Union level, we see that there's quite a substantial growth in the number of metadata records, in the number of implementations, and we see the same happening with the number of services. Download services, view services, and metadata services. So really, from our point of view, Inspire is making a difference. Currently, there are more than 7,000 data providers that have already contributed their data to Inspire. We're going to see an increase of that number. As you probably know, the deadlines for the full implementation of the directive are approaching in 2020. So we are very likely going to only see an increase in those numbers. Diving a little bit into the details, Inspire on a legislative level is completely neutral from a particular technology, so it is a consensus-based approach from day one in the drafting, in the developing of the specifications, and there are many solutions, as you see from the slides, both proprietary and open source, so everyone can choose whatever makes most sense for them. The same applies for the different standards. If we talk about download services in particular, there are several technological options available, each of them coming with a separate technical guidance document. So implementers can choose between atom feeds for their download service, web coverage service, if they are to be serving multi-dimensional coverage data, for example, web feature service for their features, so more of this static geospatial data. And most importantly, within the context of our webinar today, sensor observation service. In terms of guidance for SOS, we have two documents made available. Simon a little bit later will elaborate more on the technical details. But the two documents, they are endorsed by the Inspire Maintenance and Implementation group. So the group that is consists of member state representatives, they endorsed those two documents. one of which deals with the necessary steps for making the sensor observation service an inspired download service, and the other one that is dealing more with what is needed in order to encode the data in accordance to the Inspire models, to then be served by the sensor observation service. How this all started, some years ago, we started in investigating SOS as an Inspire download service, looking into, we first of all started by mapping the Inspire terminology to the SOS terminology to try to understand how those two initiatives relate to each other. After that, we had a technical subgroup within the context of the Inspire maintenance and implementation framework, where volunteers were contributing with their expertise, and we addressed service aspects as well as data and encoding aspects. In terms of data encoding, so this is one of the documents that deals with this topic. There's very flexible way of handling the data encoded as observations and measurements in Inspire, depending on the particular use case, depending on what the users need. There are opportunities for going to selecting a particular type of encoding that would make, let's say, the users happy. I think that, yes, the 52 North SOS solutions supports these types of encodings, as well as the necessary operations of an Inspire download service. So I think Simon later on will elaborate on that topic a little bit more. Allow me to also, in the end of my short intervention, share some recent developments, some things that we've been working on in 2018, again in an inclusive manner with several experts who volunteered to contribute. We investigated the new Sensor Things API OGC standard from the point of view of Inspire, something very similar to what we did with the SOS some years ago. So there was a paper recently released on that topic, and I think this only, it doesn't really compete with any of the possible solutions, but Sensor Things API, we just provide another idea of how Inspire might be implemented for those who are possibly interested in our IoT use case. So as mentioned, Inspire is completely neutral from the technological point of view. So from our point of view, the more opportunities there are, the better. Other recent developments within the framework of the Inspire Maintenance and Implementation Group, there are two actions that are currently trying to push for the technological evolution of Inspire that are relevant to our discussion today. The first one is dealing with alternative encodings for Inspire data. By alternative, meaning alternative to GML and XML. So there was a survey that was recently launched for input on what are from the users the encodings that would be interesting for them. No surprise that JSON was one of the most highly desired. So now the group is working on coming up with encoding rules, so departing from the Inspire models, coming up with encoding rules for JSON. And then the other group, highly relevant as well, is investigating the topic of improved client support for the Inspire data, because the idea of encoding for the with the intention of unlocking the data for data interoperability makes very little sense if we're not able to consume the data in an easy manner in the most frequently used software solutions, both in terms of desktop, but also libraries, mobile, web, and so on. With this very short overview, I would like to now stop, and I think I give the floor back to Simon to go ahead and elaborate more on the technical details. And I would, of course, be glad to answer your questions and provide input to the discussion. So with that said, Simon, I will now give you the presentation rights.
Okay, thank you very much, Alex. Now I would like to give some introduction into the technical background of the solution which we are talking about today. So Alex already mentioned that in the Inspire context, we are dealing with different types of spatial data, and observation data is one of them. And like the web feature service for feature data, so vector geometries, we also looked at a way how to have an optimized way to share observation data via Inspire. And for that purpose, we especially had a look at the suite of OGC sensor web enablement standards. So I will give a quick introduction into the set of standards here now. So what this slide shows basically is the amount of integration efforts that you would have without using standardized interfaces. So imagine you have 3 environmental agencies, perhaps one regional environmental agency, some national from different countries, and they share their data via the web, and they shall be integrated into different applications like a GIS, a web client, or some kind of analysis tool like a statistics language such as R. You would have to link to each of these data sources from each of these data consumers if you are not using any kind of standard. So the motivation for the sensor web standards was to facilitate these data flows and to reduce the integration efforts necessary for getting data into applications coming from different data sources. And to address this issue, the suite of sensor web enablement standards was developed. And for that purpose, the idea is now to have a common interface for data access on top of different data providers. So the existing data infrastructures can remain unchanged, but you just put an additional interoperability layer on top of that, which allows you to share data in a standards compliant way. So as you can see here, the idea would be that the data providers use a common standard for sharing the observation data. On the other hand, for transmitting the data via a network, they would rely on common encodings for the data, common data models, which would be the OGC and ISO observations and measurement standard. And then the data consumers would just have to talk one language for asking data from different sources in the web. So we would have 2 standards here, the SOS, the Sensor Observation Service, as a common interface for accessing the data, so how to ask for data, and OGC observations and measurements as an answer to the question how to encode the data. So access interface and encoding are the 2 elements here covered by the sensor web standards, and as well as by the 2 technical guidance documents already mentioned by Alex. So just a quick overview on the whole suite of sensor web standards. Besides the SOS for data access, there are also other elements in that suite, like the sensor planning service for controlling and tasking sensors, Not a direct part of the SensorWeb suite, but also related as an OGC standard is publish subscribe for push notifications or event-based data delivery. So push-based data delivery, and on the other hand, a range of data formats, such as observations and measurements for encoding the data, a specialization of observations and measurements, which you may have come across already, is WaterML. So WaterML 2.0 is a specialization of O&M for serving hydrological data, which is quite popular by in the hydrology domain. And on the other hand, for encoding also metadata, we have a standard, the sensor model language, SensorML, which provides one opportunity to provide detailed metadata about the processes which have been used for generating certain data. So you see there's a quite comprehensive framework for integrating sensors into web-based infrastructures, but what you should remember is that there's observations and measurements as a, as a common data format, and the OGC Sensor Observation Service as a common data access interface. So let's have a closer look at the OGC Sensor Observation Service standard. So it is a web interface, an interface standard for accessing observation data and metadata via usually web services, and it follows a pull-based communication schema. That means, like you may know from other OGC services, you send a request to that to a server where you tell the server which type of data you are interested in, and then the data returns to you a corresponding response. That's pull-based communication, request-response pattern. Important operations of the SOS are get capabilities. You may know that from all other types of OGC services. So basically getting a self-description of a service instance that includes all the metadata, supported operations, and now for us here in the Inspire context, it provides you also information about the available data sets delivered by such a sensor observation service instance. So that's especially for the metadata about the service. For the metadata about the sensors, you may use describe sensor. So there you get detailed description, how certain measurements were acquired and which process was used for that. And finally, perhaps the most important operation, get observation, that allows you to request a certain set of observation data from an sensor observation service instance. So with that operation, you would define, I'm interested in a certain set of data and I want to download that. Then there's additional functionalities such as transactional operations, which allow you to publish your data, the result handling operations as a complementary way for a more lightweight text encoding style transmission of data, and spatial filtering as an extension for dealing with observations that have a specific spatial reference that's especially relevant if you're dealing with mobile sensors where each measurement is taken at a different place. The SOS standard relies, when it's used, on the ISO and OGC observations and measurement standard. So the SOS standard itself tells you how to get the data, and it uses this observations and measurement standard for encoding the data that you have requested. So that's the quick introduction into the SensorWeb standards and the OGC sensor observation service. And now we are going to try to map this to the Inspire functionalities. So if you are dealing with Inspire download services, perhaps some of you have already dealt with other types of Inspire download services, such as the web feature service or atom feeds. And then you may remember that the Inspire technical guidance requires two classes of functionality from download services. So one is mandatory, which is the predefined dataset download. That means that you can ask such a download service for returning you a complete, previously defined dataset as a whole to you. So that's especially if you look at Atom, a typical functionality where you can reference full datasets and download them. And with the SOS, we have a similar operation. Here we are using the get observation operation with a certain parameter. Basically, you ask the Sense Observation Service to return you a complete data set, and this data set is identified by the SOS concept called offering, which is some kind of subdivision of the data delivered through an observation service. Besides the data access operation, you usually have also the requirement to get the metadata about such a service. For that, like for other OGC services, you would use the get capabilities operation. For describing your spatial data sets, you would also go for the get capabilities operation in order to download a list and compact information about these available data sets called offerings. And then for linking to the SOS as a download service, there you can put that you can use the catalog service. So that's the predefined dataset download, which is mandatory, which can be quite easily covered by the SOS. And the second functionality, which is not required by Inspire, but it's quite useful, is the direct access download, which is also defined in the specifications of Inspire, which allows you to subset the available observation data into those amounts of data that you're interested in. So for that, you may, for example, ask a certain subset of a data set, like you may have a temperature data set covering all temperature measurements for Germany for the last 10 years. That would be quite a huge data set. And if you are just interested in the temperature during the last month in the city of Cologne, you would only want to download a subset of this. And for that purpose, you can use the direct access download operation, which uses also the get observation operation of the SOS, but with a broad range of different filters that you can apply to the data, so to make sure that you only get the data that you want. And here, the nice thing is, as soon as you set up an OGC SOS as a download service, you immediately have supported both of these ways to access the data, because the SOS by default brings already a broad range of different filter parameters that allow you to subset the data as much as you like. So that's the overview of mapping the functionality required by Inspire to the SOS standard. And then we can go ahead and see what additional informations are necessary for making the SOS an Inspire compliant download service. So we have seen the functionality of the SOS maps quite well to what Inspire is requiring us, but there are additional elements which have to be added to default SOS implementations in order to be in line with the Inspire requirements. That's comprises, on the one hand, the provision of service metadata, where you have some additional Inspire metadata, such as the metadata point of contact or the type of spatial data service. Then we need to deal with information about supported coordinate reference systems, as well as metadata about supported languages. So that's service metadata, which have to be provided in addition. Also for the data sets, so in the SOS called offerings, we need to provide information about supported languages and CRS. And of course, as we are providing data or are able now to provide data in different connect reference systems and languages, we also need, of course, request parameters supporting these different ways of getting the data. So that's the extension necessary for default SOS servers. That's quite common here. And then we have some additional recommendations. So in the technical guidance, you will find information about the so-called get data availability operation, which gives you a more fine-grained access to determine the data sets which are offered by an SOS server. There you can do some further research on getting information which data sets may be relevant for you. We also introduced there some way to structure the data sets that you have into hierarchies. For example, if you're operating a measurement network for a whole country, it may be useful that you subdivide this large data sets delivering data for the whole country into individual subsets for the different stations that you may have. So here we introduce some hierarchies for also mapping that to a more fine-grained structure. So that's the conceptual part, and this has also been implemented. So there's a full implementation of these two ways to get the data. The predefined data set and the direct download functionality is available. It's part of the 52 North SOS server, which also features some additional functionality like specifics for handling air quality data and the e-reporting workflows required by the European Environmental Agency, or the handling of hydrological data through WaterML and the SOS hydrology profile. So there are different extensions available. Alex already mentioned these different types of observations that are defined in the Inspire technical guidance on the use of observations and measurements. And typical data sets that we are dealing with are time series data, perhaps also trajectories. Trajectories would be a measurement which is taken along the track of a moving sensor platform. One example are research vessels which travel across the sea and are measuring, for example, salinity at different positions, which results in the end into a trajectory along which the measurements are taken, or profile observations which go along a vertical axis into the depth or into the height and deliver then information of a certain property in different heights, for example, the air temperature in different heights above the ground. Besides that, there are further types of observations like point observations where you just take a single observation at a point in time at one location or at multiple locations. So for that, there's a very nice decision tree, which was also shown on one of the slides of Alex, which allows you to choose the best observation type for the data that you want to share. Besides that, in cooperation with BRGM, this implementation was extended to support result filtering. That means querying results by the values that were observed. For example, ask for temperature data above 30 degrees. That's another thing. We have the support of the hierarchical management of procedures and data sets that I already mentioned. And then there are some further functionalities for managing the SOS server or a complementary REST API for facilitating the client development so that you do not only have to deal with XML when building some visualization of your data. So now we come to the question, how can you work with that server if you want to share your data from your infrastructure? And for that purpose, this implementation is quite flexible to work, for example, with different database management systems. So if you are storing your data in an Oracle, Postgres, MySQL, Microsoft SQL server database, that can be easily linked to such a SOS implementation. Also, by applying, for example, object relational mappings, you can configure the SOS to different data sources. So that's an open source implementation, which is available for free on the web. And also one recommendation on the OSGeo Live DVD, which is a project of OSGeo, which is a bootable DVD or an image of a DVD, which allows you to try out the server without installing that in your hardware. The next version will be extended a bit, where we will serve a first selection of Inspire compliant data access here. For that starting point, we will go for some air quality data, at least from Belgium, which allows you to play around and get a feeling how that service works without getting your hands dirty by installing it on one of your machines on your own. So that is then complemented by some viewing applications. So for example, the Helgoland data viewer, and here what you can see, there are, for example, SOS servers operated in Belgium and Netherlands serving air quality. And here you can see how it is possible by using such an interoperable interface to easily connect to these different servers in the different countries, get the data into your applications and visualize the data together. So here we have ozone measurements from the Netherlands in blue and the Belgium data in green, and from two randomly selected stations in these countries. And there you can get near real-time data comparing such environmental phenomena thanks to the interoperable standards that are applied here. Alternative set I mentioned, so that first example was time series data, where you show how data changes along the time at a certain selected point. Another point may be trajectory data. Here we have a set of data taken along a trajectory of a ferry traveling from Germany to Finland, measuring salinity. So here's some other type of observation data, trajectory data visualized as well, also served based on the INSPIRE technical guidance recommendations. So if you want to put that into your data, into your own infrastructure, if you want to share your data with an SOS server, you can apply different patterns. And here, just for an introductory purpose, some typical strategies. So you may couple the SOS server to your existing database by doing some programming and developing a customized data access module, which is then totally specific for you, maybe optimized to your individual needs. However, it involves some programming. So to avoid that, there are different strategies to deal with that. For example, you may expose your data as database view that emulate the default data model of an SOS server. And then you could use some default data access module of existing implementations. That's a strategy which has worked quite well. Other options are that you use a default database of the SOS implementation and then import the data from an existing database for a publication database, for example, by internal database scripts. That's another typical strategy. Or you may use even feeder applications. So in some cases, we have been dealing with scientific observation data. And in that case, feeders were used for putting data into an SOS server using some standardized transactional operations and putting the data into that server. The advantage of this would be, for example, that you would not have to deal with any internal details of the database or the SOS server. Instead, you could just go for the standardized operations, put the data via XML into your server, and you are fine. So there are different strategies. I just wanted to quickly illustrate them. And there is different strategies available for selecting the best way how you could implement that in your own infrastructure. So typical questions that you should think about is if there's already an existing database which should be used for the publication. How complex is an existing database? Is a mapping to a typical SOS data model feasible or not? Performance requirements, if there are specific things in your database which should be considered, then other ways may be better than just a Hibernate mapping. Or you should also decide if you prefer to work a bit in your database, for example, to expose database use, if you would prefer to do some configuration by creating object relational mappings, or even if you prefer to do some programming. So there are different strategies, and depending on your individual needs, the best thing can be chosen. And if you are interested in this topic, there's also some further resources available if you are interested. Okay, with that technological background introduction, I would now like to hand over to the team at BRGM, who will talk about their application and implementation they did at BRGM during the last years.
Start speaking. Hi everyone, do you see my screen?
Yes.
Fine. Thank you, Simon, for this kind of introduction and offering you the opportunity to present what we do in BRGM. So for people that don't know what is BRGM, this is a French local survey. We are working on several topics related to geosciences, such as geology, hydrogeology, geohazards, such as seismology, volcanology. And as a public organization, we are concerned by several INSPIRE themes, such as, of course, geology, but also mineral resources, environmental monitoring facilities, soil, natural waste zones. So plenty of opportunity to work on INSPIRE topics. Very important thing is that we have open data policy, so we publish all the data we provide, except there are also exceptions depending on the project. And of course, we have a lot of observation measurement, groundwater quantity, groundwater quality information, soil observation, and chemistry. So as we have a lot of observation and measurement, this led us to investigating the possibility to use the source standard. So this is something we do since 9 years old. The information you can get from it is just, you don't have to work on 9 years on it to have it working, but just that we are working out since 2009. So this was the first experience to provide groundwater levels. This was with source version 1.0. And in 2009, it was apparently an obvious way to propose a donor service for time series data, as it was offering filtering possibilities on event time, observation, observed property, feature of interest. So very interesting if you want to know what your sensor are monitoring and you want to get some special data depending on the event time. So we work on it since 2009, and as for now, in 2018, so source is definitely part of the BRGM architecture for donor services. We have several instances deployed, and we do not use source only for time series, but for other kind of data. So let me show you that. So we have running instances that provide groundwater level measurement based on WaterML2 part 1, so for time series. We have also an extension of it that is enabled to handle data we get from models that for the groundwater level, so also based on WaterML2 part 1. We are also using, this is typical geology use case to provide information such like geology logs. So you get a small picture on the left that show you the representation of a geology log. Basically, it tells you that, well, you have this kind of lithology from that depth to that depth, and etc. So we use it to provide information about earth materials, so lithology, geologic age, stratigraphy, and it is based on groundwater ML2 geologic log coverage. And so a dedicated instance for it to provide this kind of information. We also have information about geothermy, so providing temperature of our system. And we plan to have other new instances for groundwater quality, for soil log, so basically the same as geologic log, but for soil, not the same depth, about soil properties, and also for soil quality. So other things we want to work on. So about the groundwater level monitoring, so we have a kind of GPRS piezometers in a network of GPRS piezometers that provide us information about the groundwater level measurements. And we get the information into dedicated databases, which is connected to 52 North source instance, and provides the result as observation measurements, and especially water ML2. So as I told you before, we have an extension of it based on the groundwater level forecast and models we have. So depending on the groundwater level source for existing piezometers, it also takes information such as meteorology, water stations, and also string gauge that are provided in JSON. So you have on the left the picture of the interface of it, and it uses data in a modeling tool to provide information about groundwater level forecast. So you can see here on the left, you have plenty of lines in different colors, in blue, yellow, red. So it depends on the different scenarios we have about provision. So it's enabled to say, depending on if we are in a dry scenario or wet scenario, what kind of groundwater level we should have. So we also provide those kind of information with sensor version service. And this is a picture of deployment of download services. So we are using both SOS and WFS. So you can see there is a very central and core concept for in BRGM and for geology, which is borehole. And to this borehole are several concepts and features and also observations that attach to it. So you can see from the borehole, you can get information such as geologic logs, lithology, chronostratigraphy. So 2 dedicated source instances. And to a borehole, you can also have an environmental monitoring facility, I would say a piezometer, that can also provide some raw groundwater levels. So this is very interesting to see that all things are connected in our system. So how we can extend it, providing the other observation we have from that kind of architecture. I also told you about the geothermal monitoring. So you can see all the system. So it's basically monitor one building we have in BRGM campus, just telling us the temperature of the system. So we can also have some very nice representation saying, okay, the temperature is increasing or decreasing, so something like that. So here are some kind of basic requests you can have. You can see we also add the kind of redirection system, rewriting system. So, for example, this first URI can give you the information about the borehole log, so raw earth material log observation. And this is basically something we provide to hide the request that is, of course, a source request, a get observation request. So that's something we're implementing to, just hiding the call of our services. And this is a way we can get raw geologic log and also groundwater levels. So extending usage, we are also supporting and working especially on the topic about having a dedicated client called the QGIS GML application schema toolbox. This is based on extension of GDAL and OGR. So it can provide you a possibility to retrieve your source servers and to get directly representation of the observation, especially for time series. So for time series, we're also trying to extend it to have a proper representation of borehole logs, things we are really using much in the BRGM. Another extending usage that Simon also told is about, extending source to be able to have some filtering on results. So basically, the reason was we want to develop a mobile application to facilitate geological facies description of the field. So basically, someone go on the field, have his application, see the geology and want to describe it. And the idea was to be able to retrieve the servers, get the data to know where in that where you are. We have already some information, some lithology that has been provided. And so if you want to describe it, we propose you to map to this kind of information we had, and it enables him to see if what he sees conform to what we have in this zone. So for that reason, we wanted to have some filtering results. It was in source 1.0, and the idea was to extend it to have it back in source 2.0. So we had a proof of concept development with 52 North. It was concerning the extension of both get observation and get data availability requests. And the idea was to have it in the source, I would say 2.0 or the next one, standard too. So basically how it works, you can see here, we want to have the logs that match specific parameters. For example, we want to get the geologic logs that have RG bleu, so this is the French translation of blue clay in a specific zone. So you can see here in the picture, you have some brown squares that show you the boreholes we have, and if you take this request, you will only have those two in the blue cycles, so the ones that have the blue clay. So that's basically the things we want to have, the kind of results, the kind of interface we want to have with SOS, and that has been developed as an extension of 52 North SOS. So as a summary, we have a lot, we use a lot the combination of both get data availability and get observation, especially if we want to match, get functions that match filters. We don't know if when we retrieve this kind of filter how much data we will get. So the idea was to be able to use get availability so we can know how much data we have, and we can also retrieve those observations independently after that. So this enabled to have the application running, we say, quite fast, or not freezing it. We also are discussing simplification of groundwater ML to geologic log coverage for results. So basically, we have lot of information telling you that we're from that depth and to that depth we have this thing, and then from that depth to that depth we have this thing. We want to compact it, have a kind of data array. So this is something we are working in the OGC borehole instability experiment, so in the geoscience domain working group, to have this kind of representation. So it would be, we would say, faster to retrieve the information and to build the representation of it. And also, we are exploring Sense of Things API usage for RESTful APIs. The one we are relying on is the first implementation from Fraunhofer. We are having a proof of concept with groundwater levels and flood monitoring, just to see what we can do with it. And of course, we were part of the publication Alex mentioned just before. So that's it for the BRGM presentation. I would be happy to answer a few questions after that if you have.
Okay, thank you very much for your interesting summary of the activities at BRGM. If you could transfer the presentation rights back to me.
Yes, of course.
Then. Okay, so then we are already nearly at the end of our webinar. I would like to provide a quick summary. So what we've seen, how observation data is becoming a complementary source of information as part of the whole INSPIRE framework. So with the SOS, the Sense Observation Service, there's now a suitable means for providing access to observation data, so that maybe any type of measurement data, such as air quality. We have seen lots of different hydrological and soil-related activities at BRGM, air quality, oceanographic data. So a very broad range of data which can be now served in an INSPIRE-compliant way. There are open source implementations. First deployments were made, such as the ones that you have seen at BRGM. And of course, the development continues. So further approaches, such as the Sense of Things API, are currently evaluated for the future. And most likely, or for example, we are also working now on one extension of our SOS server so that you get this interface integrated as well. But in general, we wanted to show you how Sense Observation Service can help you to share observation data in the context of INSPIRE, and we hope that this was useful for you. So before we close, just a quick hint, if you're interested in this topic a bit more, at the beginning of September, from the 3rd to the 5th, we will organize our next edition of the annual Geospatial SenseWebs conference here in Münster, where we will have several presentations from practice and also some tutorials at the beginning, which give you a further introduction into this topic. So if you like, we would be happy if you join us for the conference in September. And with that, we are at the end, and I would like to hand over to Anne again to see if there are any open questions. So in that case, we would have the time to discuss them now.
Thank you, Simon. I do not see that there are any questions here. Maybe I would just like to ask in the round if there are any, and if not, I would like to thank everybody for joining us. We are planning to continue this series with different topics, and if you are interested in being notified about it, you can also send an email to our info@52north.org, as well as if you would like to be informed about when the webinar will be published. So I don't see any more questions, so I would like to end it here, and thank you all again, and thank you for joining us.